In this video, we are going to talk about electron configurations. Electrons occupy three-dimensional regions of space called atomic orbitals. Each orbital has its own shape. For example, here's the nucleus, and then you have like an s orbital, a 2s orbital, some p orbitals. As you can see, when I'm drawing the atom, it can get very complex. So one way that we simplify atomic orbitals is to use orbital diagrams such as the one shown here. Orbital diagrams are models that help us visualize how the electrons are organized around the atom. Atoms tend to exist in their ground state, which requires electrons to be arranged so that they occupy the lowest energy levels. As the diagram shows, we see that the energy levels start at 1, increase to 2, and then 3, and so on. Within these energy levels are subshells S, P, D, and F. Now, within each subshell are orbitals. Each orbital holds 2 electrons. So you can see in the 1s orbital, that holds 2 electrons. When we move to the second energy level, now we're in the 2s orbital, which also holds 2 electrons. And these orbitals, the s orbitals, are shaped like spheres. When we move over to the 2p orbital, we see, or the 2p subshell, we see that it has 1, 2, 3 orbitals and thus holds 6 electrons. As I show kind of in the diagram, the p subshells are shaped like dumbbells, having 3 orientations in space. As you move up the energy level and we see the 3D subshell, it has 1, 2, 3, 4, 5 orbitals, meaning it can hold 10 electrons, and the F subshell has 7 orbitals and can hold 14 electrons. Now let's try an example. Magnesium has 12 electrons. The Aufbau principle says that electron orbitals should be filled starting at the lowest energy level. So using our diagram, we can figure out the order, which is 1s, 2s, 2p, 3s, 3p, 3d. And so on. So now we can start writing our orbital diagram. So we know that the lowest energy level is 1s, which has 1 orbital, meaning it has how many electrons? 2 electrons. The Pauli exclusion principle says that within the orbital, the electrons must have opposite spins. And the way that we denote the spin is the direction of the arrow. So within the 1s subshell, we can put 2 electrons, one going up and one going down, to signify the direction of the electron spin. Following Aufbau principle, our next subshell that we will fill goes up to energy level 2 and is now what? The 2s level. So again, with s, we have how many orbitals? 1. And within one orbital, we can hold 2 electrons. So again, following the Pauli exclusion principle, we have 1 electron that spins in this direction and another electron that spins in the opposite direction. And that fills the 2s subshell. The third rule that we want to talk about is Hund's rule. And Hund's rule says that negatively charged electrons repel each other and impact the distribution of electrons in orbitals. Therefore, each electron must occupy a single energy orbital before additional electrons with opposite spins are added. So, following Aufbau's principle, we know that what is our next energy subshell that we want to fill? That would be the 2p subshell. So, 2p has how many orbitals? 3. And because each orbital holds 2 electrons, we know that 6 electrons fill the 2p subshell. But with Hund's rule, we add 1 electron to each orbital before adding an additional electron with the opposite spin. Okay, so now we have 10 of the 12 electrons that complete the magnesium electron configuration. So what would our next subshell be? 3s, which has how many orbitals? 1. And within that orbital, we have 2 electrons. So now that we know the placement of our 12 electrons, we can write magnesium's electron configuration. To write the electron configuration, we start with our first subshell, which is 1s, and the 2 stands for the number of electrons in that subshell. So that's followed by 2s2. Then we have 2p6. And finally, we have 3s2. So this is magnesium's electron configuration. So to recap, we fill the orbitals starting at the lowest energy level, which is the Aufbau principle, making sure that each orbital contains 2 electrons with opposite spins, which is the Pauli exclusion principle, and that we occupy orbitals each with 1 electron before doubling up, which is Hund's rule. So you will see when we were filling out the 2p subshell that if I only needed 3 electrons in that subshell, then each of those orbitals would have an unpaired electron. And because these unpaired electrons can spin in either direction, this results in magnetic moments in any direction, and this capability allows for paramagnetic atoms to be attracted to magnetic fields. This is an example of how the electron configuration impacts the properties of elements. So these are the steps for ground state electron configuration.